Okay, but this session, there's a lot of concept that you have to understand. Okay, so let's begin today's session. So far, 5 people is present over here, but anyway, we'll continue the session. Okay, so today we'll be focusing on more evidence-based, and this is to do with more calculation. This is the part of the section where you need a calculator and you need a lot of, concept to understand. Yeah. So when we are talking about variables, it's also it's important to understand when we are talking about critical appraisal, what are variables? So anything that can be measured or modified in a research study is called variables. So the variables are most commonly used in the RCT because they can be measured and modified. Okay, so the independent variables are the one which are under the control of the person who is doing the research. Dependent variables depends on the value of the independent variable. Okay, so let us take an example. If you are doing a study that smoking causes lung cancer, and smoking is the one which is under the control of the person who is doing an experiment. Okay, so they have got a choice whom to include in the study and whom not to include in the study for smoking. So the data that are collected, they fall in the independent variable, and the outcome, okay, which is the lung cancer, which depends on the independent variable, are known as a dependent variable. Okay, so this you need to understand. When in the critical appraisal, if they give a big, what we call a big question, okay, Fatima, okay, so we have just started the first slide. You haven't missed a lot. Okay, so this is the first slide. Yeah. So let me just give you the things that we are covering today. Let me recap. So like last session, the session is 3 hours. Every session is divided into 50 minutes, a 10 minutes break. So in the first session, we'll be covering variable, descriptive statistics, and graphs. Okay, so these are the topics we'll be covering in the next 50 minutes. And we have got a lot to cover, so my pace will be faster than the last time. Yeah. We are also recording this session because compared to the last session, this will also give you an opportunity for you that, if you have missed anything, and since 3 hours is a long time, I know that it's difficult to, concentrate. So if we record it, you can look in your own time, the sessions. So the first thing we are covering is the variable. So variable is defined as something which can be measured or modified. Most of the time, the variables, if any question related with variable comes, make sure they are RCT study. Okay. So in variable, there are two types of variable you need to understand. One is independent and one is a dependent variable. Independent is the one that is under the control of the person who is doing an experiment, and dependent is the byproduct, which is like, if you take an example of smoking, the person who is doing a smoking can control whom to record, whom not to record in the study. Okay, recruit in the study. So they fall into the independent variable, and the byproduct, which is the outcome, like lung cancer, which depends on the independent variable, is known as a dependent variable. Okay, so is this concept clear to everyone? Yeah.
Yes.
Okay. Now the term called parametric and non-parametric statistics is also very important. We have already covered what is qualitative study. Okay, would anyone want to give a shout? What do you mean by qualitative study?
In qualitative study, you don't deal with numbers. That's what I know about
Feelings, attitudes, opinion.
attitude, yeah.
Okay, so if any scales, rating scales or anything comes with that, it falls into non-parametric statistics. Keep that in mind. Okay, so anything which can be measured, okay, quantitative, it falls into parametric statistics. Okay, so this is also very important, okay, to understand the concept of parametric statistics and non-parametric statistics. In parametric statistics, we'll come through a graph which is called a bale-shaped graph in the graph section. Okay, so at this moment of time, Just keep in mind, if there is something to do with non-parametric statistics, that is qualitative. If something to do with quantitative, is parametric statistics. Yeah. Now let us go more depth into qualitative variable and non-quantitative variable. In qualitative, is divided into two parts. Nominal is, they are not related with each other. So let us take an example of male and female binary data. Okay, in nominal, the other example might be ethnicity. Ethnicity, it depends on race. Okay, so that all falls in the nominal data, which is also categorical data. And the other one is called ordinal. Ordinal means you can rank from worst to worst to better. So some of the examples are cancer rating, or you can also take as pain rating. So the ordinal, that is an example of ordinal. So the formula that I always keep in my mind is NO for qualitative, and for nominal. Nominal, it can be binary or ethnicity. If it's ordinal ranking, that is for the qualitative. So the formula is NO. Now the other one is quantitative. For quantitative, there are two types: interval scales and ratio. Okay, in the interval scale, the difference between 2 points are equal. Okay, so let us take an example of a temperature. Okay, so the difference of a temperature between 99 and 100 and 98 and 97, the intervals between them are equal. Okay, the difference between interval and the ratio are, in the ratio there's a true zero that actually exists. Okay, that means, like, for example, the height can be, the weight can be zero weight. Okay, it can also take so in simple terms, just remember height and weight, it's a ratio. In the ratio there's O, so the zero. Okay, so if any question that comes says that the true zero really exists, what is the type of a variable? Close your eyes and tick on ratio. Furthermore, the interval and the ratio, it can be further divided into two groups: continuous and discrete variable. Continuous is, it takes any fraction. Like, let us take an example of a weight. Okay, so the weight can be 98.2 kg. Okay, the height can be 5 feet 6 inch. Okay, so it takes the fraction. Discrete is, it takes the variable. It cannot be in a fraction. So if you are talking about discrete variable, it can be number of children. You cannot say the number of children is 2.5. Okay, so is this clear to everyone? Both for interval and ratio, it can be continuous and discrete. Okay, so it's very, very important to understand these topics. When you understand this topic, it becomes easier for us to solve some of the questions which might come on variables. Okay, before I move to the next slide, is everyone clear with the variables, different types of variables? Yeah.
Yes.
Okay, so let me move to the next one. Now we have finished the variable.
How is the ratio? How is the ratio can be discrete?
Which one?
The ratio numbers like height and weight and all the things. I think all of them can be.
It can be discrete as well as it can be as I said, ratio can be either continuous or either discrete.
I mean,
okay, but the height and weight, most of the time it can be fraction.
yeah.
Let us take, the height can also be 78, 68, without any fraction. Does that make sense?
Yeah.
Yeah, it's not necessary. For example, if it is a fraction, it falls in a continuous variable. If it just takes the number without a fraction, it becomes discrete variable.
Okay.
Is this clear now?
Yeah.
Yeah. So in your exam, if they give like 78.2, what kind of variable is it? So you put ratio and continuous variable. If they put just 78 kg, the answer will be ratio, which is discrete variable. Yeah. Okay, so let us move to the next topic. Now we are covering the descriptive statistics. Okay, in descriptive statistics, these are the topics we'll be covering: mean, median, and mode. Okay, so there are two graphs. One is the bar graph, one is the histograph. So what is the difference between these two graphs? Would anyone want to comment? Bar graph and histogram.
I think the histogram is a continuous data.
Yeah. Like the example is age. You know, like if you are getting a difference between like a group between 0 to 5, 5 to 10, so it's continuous. And in exam, if they just give the diagram, okay, and if they ask you to name what type of graph it is, if there's no gap, it's a histogram. If there's a gap, it's a bar graph. That's the simple way of remembering. Yeah. Now, the mean, medium, and mode, it all falls in the category of central tendency. Okay, so keep this in mind, central tendency. So if they ask any question and if they say, can you name which one in the central tendency? If you see any of these three terms like mean, medium, and mode, you tick on that. Okay, so the way we calculate the mean is the sum of all the variables divided by number of values. We have some of the MCQs, so I think this will be much clearer when we do an MCQs. Medium is the median value when the data are arranged in from ascending to descending order. The value which is in the middle is a median. Mode is the one which most common occurs in that data. Okay, so when we do an MCQ, it becomes more clear. Now, this tends to ask more common. For example, if the data like 1, 2, 3, 4, 5, they are arranged without, with a single interval, then we call as a normal distributed data. Okay. But for example, if the data are collected, with a higher value on the right hand side, the mean becomes more. So that are positively skewed data. If the datas are, most of the smaller data are on the left hand side in the distribution is called negatively skewed. So that's the simple definition. But when we do some example of MCQs, this concept will be clear. They tend to ask this graph, common, and they will ask, which one of the graph is it? Is it positively skewed? It is normal distribution, or it is negatively skewed? So the way to remember this graph is if it is a normal distributed, all mean, mode, and medium, they are on the central. So it will be like a basic. Okay. In an exam, if you have time pressure, always keep a hand like this in front of a screen. Okay. And this is your right and this is your left. Okay. And no matter what, the medium always falls in the middle. Okay. So consider in your right hand side, if there's a mean, okay, if you turn on this side, is positively skewed. Okay. If it is positively skewed, you will get the longer tail of mean on your right hand side. So remember, your right hand side is always positively skewed. Okay. For negatively skewed, remember the mean is on the left hand side and turn to your left, and wherever the mean is there, the tail is longer on that side. Okay, so that becomes negatively skewed. Okay, so is everyone clear how to remember in the diagram? In the diagram, what they tend to do is they don't put the mode, medium, and mean in the graph, but they will ask you, is this graph positively skewed, negatively skewed, or it's normal distribution? So is this clear to everyone how to?
Yes.
Yeah.
Yes.
Yeah. So always put a hand like this. Okay, so let us do this example. So I'm going to give you 1 minute to everyone to solve this one. So in this, there's MCQs, which says positive modification program for reducing the excessive weight in patient taking clozapine. Weight change in kilogram. So on the left hand side, there's a number of the clients. On the right hand side, that is the kgs. Okay, so there are 11 people in the clozapine clinic. It's ordered in the magnitude. So in this one, what is the mode? So you have to calculate the mode. You have to calculate the median, and you also have to calculate the interquartile range of the weight difference. Is anyone clear what is this interquartile range? Has anyone heard this term before? Interquartile range.
Yeah.
Okay, so
Yes.
remember, if there is a normal distribution, the 50% is the median. Okay, so between 50 and 100, there's 75. Okay, between 50 and 0, there's a 25. So the difference between 75 and 25, that is the interquartile range. Okay, so I'm going to give you 1 minute. If you have your answer, please can you show the thumb sign with emoji once you get solve this question. Imagine this question came in your exam next week. So mode is something, if you look on the right hand side, the one which appears most of the time, which is the number?
Mode is 5.
5. Okay, what is the median?
7.
7.
Okay, so 11 divided by 2, so it should be something between 5 and 6. So we always take the number before, so that is 7. Okay, so what is the interquartile range? So you try to find out which is the 75 and which one is the 25. You look on this one and you subtract, you will get the interquartile range.
Is there any way to find the 25th and 75 if there is a large number of numbers? This is a few numbers, so we can do it. But if there is a large numbers,
Okay.
is there any way to find the?
Okay, so the formula to find the 25th is n divided by 4.
N divided by 4.
4. Okay, so that will give you the 25th. To get the 75, 3 in 3 into the number, like the number is 11 divided by 4. So that will give you the 75.
Again, n by 4
No,
gives
no,
the 25th.
For the 25th, n, which is the number over here,
Number?
divided by 4.
Okay.
That will give you the 25th. Okay.
Right.
So whatever you get, multiply by 3, that will give you the 75th. Is that clear?
Yeah.
Okay, so after you get that position, just look on the other side, to the right hand side. Okay, whatever number is there, you subtract, that will be the interquartile range. Yeah, so just checking. So imagine this is the option. Has everyone got this answer right? 5, 7, and 4. Yeah.
Yes.
So let us also do this one. Okay. The number of days of a series of 5 patients have to wait to get a CBT. So these are the number of days: 12, 12, 14, 16, 21. The median for this median, what is the median waiting list for CBT?
Number in the middle. 14.
14. Yeah, in the middle. So this data, is it positively or negatively screwed?
Positive skew.
Why? For this, the easiest way is try to find the mean. Okay, if the mean is more than the median, is a positively screwed. So that's an example. To calculate the mean, what you have to do is you have to add all of this divided by 5. So you will get the mean. Okay, so if the mean is more than the median, that is positively screwed. Does that answer your question? Statistically, yes. Yeah. Okay. Okay. Frequency distribution graph shown in the mean. Mean is to the left of the median. The mode is to the right. The distribution is which is it positively or negatively screwed? Remember, right and left hand. So the mean is to your left-hand side.
Negative square.
Negative squared.
Okay, so as long as you put your hand and mean right or left, so it will give positive or negative. Yeah. So this one, what distribution is it? So look at the median, mean, and compare with the median. Is it positively,
It's
negatively?
positive. Positive.
Yeah.
Positive,
Yeah.
mean higher.
Okay. Yeah. Okay. So let's move to the next one. Yeah. Now the topic that we are covering is measure of dispersion. Okay, so this is more complex than the central tendency. Remember, in central tendency there's a mean, median, and mode. Okay, but in measure of dispersion, you know, this is more complex thing than the central tendency. In this one, you don't need to remember the definition of each all of them, but you need to remember the formula. In the formula, the variance, the formula is sum of the square root of each of the item in the distribution of the curve. So it's very complex to understand this one. In the basic term, what we can understand is variance is you get the mean. Okay, so this is the mean. Can you see my arrow?
Yes.
Yeah. Then this is like the individual items or number. You subtract that and into the square root. So plus you do with each individual number and divided by the total number of the sample. So that will give you the variance. Okay, but in your exam they don't ask this one, but sometimes they might just put this diagram and say, what is this symbol stands for. Okay, so that's simple. This is variance. Now the standard deviation is the square root of the variance. In your exam, they will ask you a very simple question. Okay, if the variance is 100, how much is the standard deviation?
10.
10. So basically, it's a square root of variance is a standard deviation. Okay, so keep this in mind, the relationship. Okay, so the third formula that we are doing is coefficient of variance. So the coefficient of variance, the formula is standard deviation divided by mean. Okay, so that is the coefficient of variance. Now the standard deviation is 100 and the mean is 10. So how much is the coefficient of variance? Standard deviation is 100 and the mean is 10.
It's 10.
10. Okay, so they will give you the simple kind of thing. As long as you remember the formula, you know how to do it. The tricky bit might be sometime they will give the value of coefficient of variance and the mean, and they will ask you how much is the standard deviation. So as long as you know the formula, you know how to do it. Like imagine coefficient of variance is 10 and mean is 10. How much is the standard deviation?
Come again.
Coefficient of variance is 10, mean is 10. Calculate the standard deviation.
100.
100.
100. Okay. Unfortunately, there's no any easy way. You need to mug up the formulas. Yeah. Standard error of the mean basically means standard deviation divided by square root of the number of samples. Yeah. Now let us take the standard deviation is, let us say 10. Okay. And the number of sample is 100. How much is the standard error of the mean?
1.
1.
1. Okay. So is this clear to everyone? Okay.
Yes.
In your exam, you just need to remember the formula, no matter where they twist and turn. Okay. As long as you know the formula, they will give you a very simple, number, and they will ask you to calculate. At our level, the syllabus says you just need to know the formula. They don't ask, the definition of standard deviation. They don't ask the definition of standard error of mean and how they are related. But remember, variance, standard deviation, coefficient of variance, standard error of mean, in the statistical term, they all follow in the measure of dispersion. Okay. Beside this topic, there are also range, interquartile range, and mean deviation we'll cover in the coming slide. Okay. So is this clear to everyone? Variance, standard deviation, coefficient variance, standard error mean. You just need to know the formula.
Yes.
Okay, so let us do this. To study the influence of various diagnosis of the duration of hospital stay, investigator calculate the ratio of a standard deviation to the mean duration for a stay in the hospital observed during the period. The ratio is called, so the standard deviation divided by mean.
Coefficients of variance.
Yeah, okay. So this is the way they ask, in your, in your MSI paper. Okay, so as long as you know the formula, you know which to tick. Okay, so that is the thing that you need to keep in your mind. Which one is not a measure of dispersion?
Mean.
Mean. What is mean?
Central tendency.
Central tendency. Okay, keep that in mind. Yeah. So let us calculate this one. 100 patient on clozapine had a blood pressure recorded after 1 dose of clozapine was given. And the mean systolic. So they have given the mean 150. If the standard deviation of the observation is 10, calculate the standard error of the mean blood pressure measured in this. So in this one, remember what is the formula for standard error?
Standard deviation over square root of n.
N. So standard deviation is 10 divided by the square root of the sample. How much is the sample
100.
is 100. So square root of 100 is 10. So 10 divided by 10 is 1. Okay, so the systolic blood pressure of 150 is given to confuse you. Yeah, so if you don't know the formula, you might use 150 in your calculation. Yeah, so that is the reason why you need to remember the formula. Yeah, okay, let me move to the next one. Okay, so this is something called normal distribution. Sometimes this graph is also known as Gaussian distribution. So in exam, what they tend to do is they'll just put a graph and they will say name what graph is it. In this one, in a normal distribution, as I said before, mean, medium, and mode, if it is normal distributed, they all are in the central. Okay, so now if you if you divide with this standard deviation, that is like between this and this. So the one standard deviation, if you look at between this and this, the area it covers is 68. If it is two standard deviation between this and this, it covers 95. Between three standard deviation between plus and minus, it covers area of 99. Okay, so this is in a normal standard deviation. Okay, so is this clear to everyone? This graph?
Yes.
Yes.
Okay. There's a formula sometime which might come. Okay, so if someone asks to calculate the standard normal deviation, the formula is the raw data, whatever data is there. So data is there minus the mean divided by the standard deviation. So that is give the standard normal deviant. I don't think they will ask this one, but if they ask, just know the formula for standard normal deviant is the raw data minus the mean divided by standard deviation. Okay, so let us do this one. The score of a new psychometric instrument that measure the working memory capacity are noted to be normally distributed in a large sample of university. If the mean score is 50, so the mean is 50 with a standard deviation of 10. Okay, what percentage of university student will score more than 60? I will give you 1 minute. Okay, if you have an answer, just let me know. And can you also give me the reason why you think that's the answer?
I think the answer is 90. There's two standard deviation one.
Why do you think it's a 2 standard
Because
deviation?
they say what percentage of students will score more than 10. So if the mean score is 50, more than 60 rather. So anything between 50 to 60 is 1 standard deviation.
Good.
Anything
Okay.
above 60 is from 2 standard deviation.
Yeah. Okay. So what's your answer if these options are given to you?
Is it 95? Is that a 2 standard deviation one?
Okay, so let us look at the definition. The score of 60 is 1 deviation, which is higher than the score in the normal distribution. So the curve will cover 68 will fall below minus and plus 2 standard deviation. So if you look at this one, at the graph, so if it is this one, plus and minus, so it follows on 68%. So they are asking how much of this it follows above. So this is the area that we look for. Do you agree with that? Yeah.
Yes,
So,
that's true.
okay, so let us look at that one. Of the remaining 32, 16 will be below 1 standard and 16 will be above this one. So if you look at this diagram, okay, 68, it covers this one. So the remaining is 32. Okay, out of 32, okay, 16 will be here, 16 will be here. Do you agree with that?
Yes, half.
Okay, yeah. So they are asking how much of it follow above this one. So what should be the answer?
Yeah, the 16 is
60.
0.16.
Yeah. So is this clear to everyone? Yeah.
Sorry, Dr. DeLong, where does the 95% confidence interval comes in? The page before this one.
So
That's the page before this one, the one you showed us. No, the graph one, the one that has the graph lines.
okay, so the 95, it follows in
Yes.
plus 2 and minus within this one, 95. This one minus and plus 3, it's 99. Is this clear?
Yeah. Thanks.
Okay, so yeah. So we have covered the measure of dispersion. Now the last topic for this session is the graph. Okay, so in an exam, there will be 2 questions on graph. So the question from the graph will be identify the graph, and sometime in the graph, some of the things will be missing, and they will ask to point, what should be in the x-axis, y-axis. Okay, so those are the things, and you also need to. The third thing is you also need to know how to interpret the graph. Yeah. If you have good knowledge of the graph interpretation, it also becomes easy when you do a critical appraisal. Okay, so which graph is this one? What's the name of this graph?
It's a consult graph.
Okay, it's used in RCT. In exam, what they tend to do is, remember enrollment, allocation, follow-up, and analysis. Okay, if they give you some data over here, that's a follow-up data. So anything that falls in the third category is a follow-up data. Okay, one more question I'm going to ask in RCT, what is the risk? Which risk is more? I think this we have already covered.
Could it be publication bias?
No. Which bias is more? Not a publication.
The information, I might be wrong.
No. It begins with A. Attrition bias. Okay. Attrition bias, and to address attrition bias, we covered 3 topics. How we can replace those attrition bias. So how can we replace? There are 3 ways to replace the missing data.
Intention to treat.
Yeah. And intention to treat analysis, it can be done by last observation carried forward, worst case scenario, and mean imputation. Yeah. So is this clear? If anything question comes, so the related questions might be, follow up, how do you address, and what they have used. Okay, so you need to know the concept if this type of graph comes. Okay, so this is an example of RCT. Randomized, allocated on each of the arm. So enrollment, allocation, follow-up, and analysis. So if you know that, you will answer whatever question is given on RCT. Okay, so this is also called as funnel plot to detect publication bias. What is the another name for funnel plot? I think this we covered the last, last slide in our last session.
I said something.
False name.
Yeah, false name.
False.
Yeah. Okay. So remember, I'm going to cover the log ratio and this in inference statistics, but at this moment of time, remember on the x-axis is a log ratio, on the y-axis is the standard error or the precision. Okay, so the precision, is it reliability or validity?
Reliability.
Yeah. Okay. So remember, x-axis, sometimes they will give you A or B and they will ask what is on the y-axis and the x-axis. So remember log, standard error, perception. So this arrow is the confidence interval. The median is the overall effect. Overall effect is the summary of all the study. In the lower side is the smaller study. In the high in the topmost is a bigger study. Okay. So this is a funnel plot for publication bias. So in an exam, they will ask you what type of graph is it. They will not give this and they will ask you, to name it, what should be there. Yeah. So is this clear to everyone? Funnel plot.
Yes.
Yeah.
Okay, so let's move to the next one. This is called box and whiskey plot. Okay, this is the plot. It's very, very common question that they ask. We need to know what are, these terms. So this one is the maximum limit. This is the minimum limit. So the difference between the maximum and the minimum, what do we call? If you subtract maximum and minimum.
Interquartile.
No. Interquartile is third and first quarter. That is the interquartile range.
In median.
No. If you just subtract maximum and minimum, it's called range.
Range, yes.
Yeah. If you subtract third and first quartile, it's called interquartile range. Okay. So the medium, this one is a medium, and this is the interquartile range. Anything above, or it can be on either direction. Outliers is when you do a study, one or two study might be off from what we expect. So that is called outliers. It can be in either direction.
Please, Dr. Gurung, for the funnel plots,
Yeah.
can we have any outliers? Like if the study is outside that confidence interval, does it have any significance?
If there's some studies are outside this one, confidence, we call as an outliner.
Okay.
Everything should be inside this confidence interval. Yeah, in most of the funnel plot, that the thing is, the people who publish this paper, okay, if any outliners are this one, it's unlikely that they are going to publish the paper.
Okay.
Yeah. So keep that in mind. Now let us do a quick question just to know how much we know about from the graph. Okay, there's a graph. Can everyone see this graph on the right hand side? Okay, on the right hand side, can you, on the x-axis there's a month, and on the y-axis there are numbers of the finding, the chloride water filter. From this one, which of the months have got the largest outliers?
This September has got 6.
1, 2, 4, yeah, 6. Yeah. Which one of the study has got the biggest interquartile range? Biggest.
May.
In May. Yeah, May.
May. Okay. So if you are confused between May and March, the best thing you do is you draw a line from here, here, and here, and here, and you subtract and which one has got the biggest interquartile range. The clue is this one, draw a line. Yeah. So if any question comes on box and whiskey plot, are you guys able to answer it now? Can I take it
Hopefully.
as is? So let's move to the next one. Box and whiskey plot depicts all of the following graphical form except which is not in the box and whiskey.
Standard
Standard
deviation.
deviation.
Standard deviation, is it a central tendency or measure of dispersion?
Dispersion.
Dispersion.
What's the formula for standard deviation?
Square root of variance.
Variance, okay. And so there's the another topic that we are covering is survival analysis. Okay, any question that you see with survival analysis is a cohort study. So keep that in mind. Survival analysis have to do with cohort study. Yeah. In cohort study, how long does it take the event to occur, time to relapse? So the outcome has not happened. In survival analysis, we try to follow the exposure till the outcome happened. As I said before, sometime the outcome might be we cannot wait for years and years. So we create something called medium survival rate. That is the length of a time survived by 50% of a sample without achieving the outcome. So we make a hypothetical endpoint that is known as a medium survival rate. Okay. So now this I think Chika, did you ask me last time about this terms log rank?
Yeah.
Cork
Yes.
regression hazard ratio. Okay, so let us understand this one. So these terms are used in survival analysis in the cohort study. Okay, in this one, if you are comparing the statistical comparison of two survival rate of two sample, okay, I'll show you the graph and this will be much clearer. So if you are just covering two samples straight from A and B, is called log rank test and it's used in survival analysis. Now there's another term called Cork regression analysis. So the Cork analysis is used if it is more complex, okay, rather than just comparing, okay, if they have also given that the two variables that we are comparing have got the confounders, okay, then we use a statistical test called multivariant, and the statistical test to address is called Cork regression analysis. We have covered confounders. Would anyone want to give an example what is confounders? We have covered last time.
Confounders, I think, are those factors that could influence.
The third factor.
Is that the third factor that could influence our research outcome? But
yeah,
we haven't really put them into consideration, so to say.
Yeah.
Like studying somebody with lung cancer and the person is a smoker.
Yeah.
Or you are studying a drug that could cause lung cancer. The smoking can be a confounding factor. Like
Yeah. So in the survival analysis, if they have mentioned confounders, okay, the statistical test that we use is multivariant logistic, but the analysis, the way we try to minimize that, the statistical test is Cork regression analysis. So is everyone clear between difference between log rank test and Cork regression analysis? Yeah. Okay.
Yeah, and cost has C in its name, so C for C, cost for confounders.
Yeah, C for C to remember. Now something called hazard ratio.
Sorry.
Yeah.
I think I've also come across Cox progression, something proportional, Cox proportional analysis or something.
So that is the thing that we'll cover in inference statistics.
Okay.
Okay. After the break, we'll cover those topics. Yeah.
Right.
Because that's a huge topic. Let us leave it to the second session. Yeah. And there's something called hazard ratio. Hazard ratios are used in a study where they mention about death from the treatment. Okay. So the death probability, if they mention anything about death in the survival analysis, they all follow in the hazard ratio. So there are three different terms that we use. It's called log rank, just to compare from A and B. Cork regression if there's confounders present. Hazard ratio if something mentioned about death in survival analysis, which is a cohort study.
Is there any difference in the shape of the graph about this log rank test and Fox regression, or it is the same as the survival analysis curve. This is the same shape of the graph.
Sorry, I'm not able to hear. Can you repeat the question, please?
Is it the same shape of the graph in the log rank test and Cox regression and
Yeah,
hazard
yeah.
ratio? It is
So the graph, you don't know from the graph whether there is a log rank, this, what are the analysis that they have used. We find it more from the description that they have given in the study. So looking at the graph, we cannot tell whether it's a log rank, Cox regression, or hazard ratio. So those things will not be mentioned in the graph. Let me explain you the graph so it becomes more easy. Okay, so this graph is called survival curve. The another name is called Kaplan-Meier's. Okay, so in your exam they will ask you about which graph is it. So if you look at it, the x-axis will be always time and the y-axis will be survival probability. So in this one they are covered, group A and B. Okay, so in group A and B, if the information is given, just compare A and B without any confounders or any depth. Which analysis have they used?
Log rank.
Okay,
Log
so
rank.
if they have given, some confounders are also present, which analysis have they used?
Cox.
Cox.
Yeah, okay. If they say, the endpoint is the depth.
Hazard ratio.
Yeah, okay. So is this clear to everyone? So that information will be given in the big question. Okay, so from looking at the graph, you won't be able to tell which is the analysis. Look at the clues which is given in the big question. Then you will be able to find which analysis they have used. Okay, so this is one of the examples, like, in this one, the trick is, you might be spending a lot of time studying, what the hell they are giving this all the numbers. Okay, so in exam, the trick is, okay, which is the graph. Okay, instead of reading all of this question, go to the question straight away and see what are the things that you need. Okay, what type of graph is this? Can you name the graph?
Kaplan-Meier.
Okay, in the graph y-axis, as I said before, y-axis is the probability of survival. Okay, so look at this one, survival. Let us try to find out what is the survival that they are looking for. So just go at the last one, major depressive. So 160 remain major depressive disorder free from follow-up. Okay, so there's something related with depression and something related with free. Okay, so the likely is probability of not having depression or depression free period. Okay, so we'll keep that option. Okay, and move to the next one. So the likely option will be depression free. Okay, this type of study has been conducted in order to produce the above graph. So what study is it?
Survival
Cohort
study.
study.
Cohort study. Okay, remember, survival analysis, you don't need to think twice. Cohort study. Okay, in cohort study, I think someone have asked me about retrospective cohort.
yes.
Okay, so in this study, what they have done is depression, and they are going backwards. Okay, to find out how many of them have this is the number of years. So they have stopped it in the years, the smoker and the non-smoker, and they have gone back. So this is the retrospective cohort. So if the outcome is already given at the end, and if they have gone back, survival analysis can only be done in the cohort study. So they are looking back. So this is retrospective cohort. Is this clear to everyone?
Yes.
Okay. Above graph is used to measure what does it measure?
Survival.
Survival.
Yeah. So let us look at the answers. Yeah. So the graph is Kaplan, probability of not developing depression, retrospective cohort, and survival rate. Okay. So to get an answer, do we need to know all of this stuff which is given on this long paragraph?
No.
Okay, so in your exam, always look at the question that is given to you. As long as you know the concept, you just need to get your right answer. Okay, so this is a trick to answer this kind of question. Okay, don't be fazed by the big paragraph which is given. Okay, so now these are some of the terms that literally you have to mug up. There's no any easy way out. So in the question they will just ask, in your study there is one independent variable and the nature is continuous in nature. Which method would you use to address it? Okay, so we have done the independent variable. Would anyone want to shine the light what is independent variable?
That the experimenter or the researcher can control.
Okay, so continuous is which can even take the fraction. Okay, so if they give you, if there is one independent variable and the nature is continuous, which method would you use to address it? The answer is Kaplan-Meier and log rank. Log rank, as I mentioned before, it's it's comparing A and B. If it is multivariate, means more than one independent variable, continuous in nature. If there's more than one independent variable, then it becomes confounders are high. Okay, then it's Cox proportion, and sometimes we also keep it hazard, but sometimes this hazard should not be here. Hazard is only related with death. If they mention anything about death, multivariant, more than one variable, independent variable, confounders comes into play. It's called Cox progression hazard. So is this clear to everyone?
Yes.
Yes.
So in this one, if the data is more like qualitative, binary independent data, male and female, if it is continuous, the method we use is mental hazard test. So remember, qualitative, which is binary, continuous, this is the test that we use. Unfortunately, you have to mug up this one. There's no any easy way out. Yeah. In your exam, they will try to write this and this. What method do you use? So yeah.
Is this one the last one mental handle? Is this one of survival curve or survival analysis?
Yeah. It also comes in the survival, but most of the time, this is something which is rarely used in the survival. But if any question comes with qualitative, and most of the qualitative study, they prefer to do qualitative study on their own rather than including in the cohort study. Okay, so that's the reason why this is rarely used. Does that make sense? Let's move to the next one. Which of the following is suitable for survival analysis? Which study would you cohort? Okay, so in your exam, if you see any survival graph for this, they will ask you which study is it. Close your eyes and cohort study. Take it. Okay, so this we have already covered. Okay, there's one more graph called path analysis. Rarely they ask this question, but remember, if something to do with this kind of box, you need to remember, what of this box stands for. So this is called path coefficient, beta regression, R-score coefficient, determined distribution, error. So you just need to remember the name. They don't ask any calculation from this kind of graph. There's something called scattered plot. Okay, in your exam, they will ask what type of graph is it? Scattered plot. So the way to remember is the same right and left hand like this. If you turn your right hand slightly outwards, it becomes the positive correlation. If you turn your negative to outside, it becomes negative correlation. If it is distributed throughout, it becomes non-linear association. So in your exam, they will only put the graph and they will say what graph is it, and they will ask whether it's positively or negative correlation, or if there is scattered non-linear. So this is the only thing you need to understand from scattered plots. Okay, so is this clear to everyone?
Yes.
Yeah. So this is called leap and stem graph. So the way you interpret is this is a stem, this is a leaf. Okay, and from this kind of graph, you'll ask to calculate the mean, mode, and range, interquartile range. So the way to read this one is easy. So this one is 1, 2, 1, 1, 2, 2. So the way you read the other one is this is 10, 10, 10, 11. So this one is 25, 25, 27. So this one is 30, 31. This one is 40, 44. So is this clear to everyone? So the way
Yes.
we read the stem and leaf graph. Okay, so let us do this one. From the sample of admission to the psychiatric ward and local hospital in the Northwest, from this graph, what is the mode? Which one is the mode? How many? No. How many observation has been made in total? So how many numbers are there in total? How many samples are here?
22.
So the trick is you just count from the leaf.
Yes.
1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 22 over here. So the other plot is called labeler plot. So the way we remember this is on the x-axis is always control, on the y-axis is a treatment. So this one is the equality, okay, and this one is if someone if the data falls within the upper of the quadrant is called treatment better than the control. If it follows on this one is control better than the treatment. This is one of the examples of the labeler plot, and the size of this circle is the size of the individual study. Okay, so in this one, can you tell how many of the studies shows better control compared to treatment from this graph?
3.
3. Okay, how many of the studies shows better in treatment more than control?
1.
1. Okay, anything which is touching is it doesn't it doesn't give a true value whether it is treatment or control benefit. Okay, so let us do one more question over here. So from this, how many of the study shows better in the treatment arm?
4.
1, 2, 3, 4. If it is control, this 1. Yeah.
1.
So is this clear to everyone?
Yes.
What
Yes.
does this graph measure? Is it heterogeneity?
So
Measure what?
So it measures, it's a comparison between treatment and control. Like if you're doing an RCT study, okay, you want to find out how many of the studies have got better treatment compared to the control outcome. So any study which follows on the upper quadrant shows that the treatment is better than the control. Anything which follows on the lower quadrant, it shows that the control is better than the treatment outcome. Very simple, you don't need to make things complicated. Just understand treatment and control. Is this clear, Emma?
Yes. Yeah.
Okay. Now this graph looks almost similar to the labeler plot. This is called labeler plot, and the way we is this one is 2 standard deviation plus this is minus 2 standard deviation. You in the x-axis it will be accuracy, on this will be treatment effect. The study might differ. Sometimes instead of accuracy they might even put precision. Okay, if the study in the question says validity, remember it's accuracy. In the study if it says reliability, it's a precision given over here. Okay, and this is line of no effect. And let us do a question so it will be more common. Okay, on this study, and remember anything which is outside this one is called outliners. So 1 and 2 outliners. Yeah. So in this study, which of the study is the outliner study? In this graph,
Is
which
it
one is
there?
the bear? Okay, so is this clear? Okay, which one of the studies? Let us look at some of the question. Yeah, which of the study shows a standard effort size value closer to -1? -1 standard deviation.
It does, yeah. -1.
Yeah. Okay, so Let us skip this one. I think the other are same. So let us take just 5 minutes break. I think the pace that we are going is slower. So is it all right if we can come and 10 past 3? Yeah.
Thanks.
we'll start in the next 1 minute. So far, has anyone got any question from the topic that we have just covered?
Yeah, just a quick one, Dr. Bro. I wanted to find out, I don't know if it's something you're also going to treat later. In terms of those hazard ratios you spoke about,
Yeah.
are you going to talk about, the line of significance, like if it is 0 or 1 or things like that? Or is that something you're going to discuss later?
Just remind me after this inference statistics.
Okay.
I might have some slides. If not, then we'll have a discussion there.
Yeah. Thanks.
So let us go to the next topic. Now, this is the big chunk, inference statistics. This is the one which is the most confusing out of all of the critical appraisal. So in inference study, what happens is there's a big population. We collect the samples from inclusion and exclusion criteria. Then we define, the sample, and based on that, the parametric, we analyze and do everything, and we make the conclusion. So this is the basic gist of inference statistics. Now there are some terms called hypothesis testing. When we are doing some kind of bigger research, on the topic that we are not sure, we want to find it out. There's something called, there's two terms that we need to be aware of. That is null hypothesis and alternative hypothesis. Alternative hypothesis in the simple term is what we are trying to achieve. Okay, so in null, if we make an assumption that if we want to show that A and B are different from each other, then the null hypothesis will be, the opposite of the statement, saying that there's no difference exist between the group A and B. Okay, so let us take this in a very simple way. We want to find out if A and B are different. Okay, so that can be also known as an alternative hypothesis, or the thing that we want to prove. Okay, in order to establish this statement, what we try to do is, we cannot do this straightforward. Okay, so what we do is we try to create the opposite statement by saying that, there's no any difference that exists between themselves, and when we try to exclude that, we indirectly prove that the first statement is a true statement. Does that make sense?
Yes.
Okay, so that's the different. So alternative, whatever statement we do, we try to disapprove the opposite one. The opposite one that we create is a null hypothesis, and the prior one is the alternative hypothesis or the true hypothesis. Okay, in a simple term. So it can be done in a number of ways. One tail is just one direction. For example, if you want to prove that A is bigger than B, in this case, the null hypothesis is B is greater than A. Okay, so in one tail hypothesis is just one direction. In two tail hypothesis, on top of this direction, they also try to prove, there's no any difference. So they also try to create one more angle. Okay, so this is two-way, two-tail hypothesis in a simple term. Okay, so let us go. Okay, so the type 1 error and type 2 error is the thing that is a bit confusing. Okay, so you don't need to remember all of this one. The way I remember type 1 error is false positive, type 2 error is false negative. Does that make sense?
Yes.
Okay, so don't go with this hi-fi, this picture and everything. The more you use your brain, the more confused you get. Okay, so the easy way to remember in exam is anything to do with false positive is type 1 error. Anything to do with false negative is type 2 error. Yeah, type 2 error is also called as beta. Okay, so just keep that in mind. Another name for type 2 error is beta. So if you look at this one, I think this diagram, is a true description. For example, in reality, this is the case, and we try to create some kind of like rating scale on this just to find out how real it is. So when we measure it, if the instrument truly measure what is in the reality, that is the true positive. Okay, in some cases, what happens is the measurement scale that we use, does not cover the true reality, but in the rating scale, it proves it's positive. So that is false positive. Okay. If the measurement truly exclude what is in the reality, it is correct. It's a true negative. But sometimes what happens is even the true positive, they are not able to pick it up, then it's a false negative. That's a type 2 error. So is this clear to everyone? Type 1 error and type 2 error.
Yeah.
Okay. Let me see. Did I miss anything? No. Okay. Now there's the power is, the power of the rating scale to truly obtain the true result. Okay, if the rating scale truly picks up the true positive or the true negative, that is the power of the rating scale. The way the power sometimes can also be calculated is 1 minus beta. This would be type 2 error. Okay, so that is the power of the study. Imagine if let us say if a type 2 error is 20%. Okay, how much is the power?
It's 0.80%.
80%. Okay, so sometimes they might trick you by a simple question. They will give you the value of type 2 error and they will ask you to calculate the power. So is power clear to everyone? Okay, so
There's something confusing me about this table and the previous table. Why the type 1 error here different from type 1 error here? Here,
which one? This one?
yeah, this one and the previous one.
I think this diagram is wrong.
Okay.
Okay, sorry, this diagram is wrong. Yeah. So there's something called a p-value. Okay, so the definition of a p-value is the probability of falsely rejecting the null hypothesis or a chance of positive being sparse. Okay, so for example, as I said before, to prove the true hypothesis, we create the null hypothesis. Sometimes what happens is the null hypothesis by default, we don't reject it, is falsely rejected. Okay, so in those cases it's called p-value. From p-value, the thing that we need to remember is, don't go with the hi-fi definition. The thing that we need to understand is if the score of the probability is anything below 0.05, then it's considered good. Okay, does that make sense? So in our exam, don't go with a hi-fi. Always remember anything below 0.05 we consider as good. The definition of 0.05 is the risk of 1:10 commonly accepted. So when we do some kind of experiment, we don't expect 100% to falsely reject the null hypothesis. There might be some kind of error, so we give a leeway that even if there is a small percentage of making a mistake, this kind of percentage is acceptable. Okay, is this clear to everyone? So in your exam, anything below 0.05 you consider good. Anything over, we consider that that is not a good study. So just have to keep that number in your head. There's one more thing called, if you do the test again and again, repeat it again, it increases the chance of having false positive. Okay, so the false positive is a type 1 error. So we need to use a statistical test just to avoid that, this kind of problem doesn't happen. So the statistical test that we use is Bonferroni correction. Is this clear to everyone?
Yes.
Sorry, what is this Bonferroni correction?
Imagine, like you do one rating scale, okay, and you keep on doing the rating scale. The more you do the rating scale with finding the true positive, there's also risk of finding false positive. Do you agree with that?
Yeah.
Okay. If there is a false positive, we cannot, there need to be some statistical tests to reduce this false positive. So the statistical method that they use is called Bonferroni correction. So at our level, we don't need to know, how Bonferroni correction is done. This is the thing that master or PhD level, they use this bonfire method. In our syllabus, they all only ask us what method is used to address multiple testing to avoid type 1 false positive. You just need to take bonfire correction at our level and the syllabus. So Emma, is this clear to you?
Yeah. There is another question. Is there any relationship between the p-value and type 1 error? Is the p-value is the same as type 1 error?
No, the p-value is different. You know, the p-value is, the definition is falsely rejecting the null hypothesis, whereas the definition of type 1 error is only to do with the false positive. So, you know, don't complicate yourself, keep it very simple. Type 1 error, false positive, p-value 0.05. If it is less than that, we accept it. The more you try to, you know, think about it, the more confused you get. So, you know, let us just focus on the exam now. Is this all right? Yeah. If you're not clear, we can have a discussion after we covered this inference statistics. So the power, there are some of the factors the power is related. Larger the sample size, you know, more the power. Larger the p-value. Okay, so I think this answers your question. Okay, if the p-value increases, the type 1 error also increases. Emin, does this answer your question?
Yeah, that's why.
Okay.
Yeah, because I found a lot of questions that there is somehow relationship between p-value and type 1 error.
Yeah, so if larger the p-value, let us say if the p-value it goes on this side, you know, if more than 0.1, the false positive also increases. The p-value, if it is less, the type 1 error also becomes less. So they go in the same direction.
Yeah.
Okay. The mean value effort, control, and experiment. The in exam they will also ask, you know, the mean effect size. You know that's a mean in the central. The just remember, you know, this is also it also impacts the power. Variation of observation. If you use more experimental people, you know, doing this experimental, the variations sometimes can also influence the power. So it's better if you have one or two, you know, it helps to control the power. One-sided test is more powerful than a two-sided test. Yeah, so these are some of the terms related with power. Okay. With a confidence interval, okay, confidence interval is the range the value is likely. So the confidence interval is the one that, you know, the one which we did of one standard deviation, two standard deviation, and three standard deviation. So the graph that we did it, that was of confidence interval. So the narrower the confidence interval, is the study better? So what do you think? Narrow the confidence interval, is it better, or if the confidence interval is larger, the study is better?
I think if larger is better.
Yeah, because more larger it includes more, you know, samples.
Exactly.
Yeah. So is this clear to everyone? Yeah. Okay. So there's one more graph called Altman sample size normal graph. In this one, you have to remember on your right hand side it will be power. In the middle, it will be significance value here, number here, and the standard difference is given here. So in exam, they might ask, you know, what is the type of a graph? This is Ullmann sample size normal graph. Sometimes they will not put, you know, the X or Y, and they will ask you to name. On the right hand side is always power. On the left hand side is a standard deviation, and in the middle is the sample size. This is the sample size, and this in the lower side is called significance value. So the way they frame the question is, sometimes they will give you, let us say, you know, the power is 0.9 and the sample is 100. How much is the standard difference? Power is 0.9, sample is 100. How do you calculate standard difference?
Is the sample size, is this the number?
Yeah. This is a sample size. Significance is given in the bottom.
You just match the rows. What's the sides?
Yeah, you just draw a line.
Yes.
Okay, so that's the way to answer this question. Now, this is the one which is complicated, which is known as a statistical test using univariant, bivariant. Univariant is if they only use, one term to study. Bivariant is if they use two terms to study, like weight and sleep. Multivariant is if they use three different things to study, like weight, sleep, and exercise. So is everyone clear about univariant, multivariant, and bivariant study? Yeah. So after this one, the second question, when you are asked to find out what is the statistical test that you use, then the next is how many groups are present, parametric or non-parametric. So what is the definition of parametric? I think this we have already covered.
Parametric, that's a quantitative data, something you can measure.
Yeah, non-parametric is a qualitative.
Qualitative.
Yeah, and you also have to find independent. Independent is the one which is under the control of experimental, and paired is if it is the repetition of the same sample. Like for example, a weight taken now and the weight taken in 3 months of the same person is paired. Okay, but if the weight of, let us say, a weight of someone is compared with someone, if the weight of A is compared with the weight of B in 3 months, that is unpaired. Those two data are not related. Or if the weight is compared with the height, those two data are not related, so it becomes unpaired. Okay, and the fifth thing you have to find out is mean or frequency count. Okay, anything to do with parametric, the statistical test is mean. Anything not to do with not normally distributed or non-parametric, you use median. That is the clue. So is this clear to everyone?
Yes.
So yeah, okay, so let us do the next one. Okay, so this is an example of a univariant. You just compare one, and if you are using univariant, most of the time it's the mean value, mean. Okay, a student test is like unpaired. Okay, two different groups are compared. If it is the same group, it's a one sample. Student T is independent, unpaired, different. If it is paired of the two groups of the same subject undergoes two observation, that's a pair T. So there are three different types of univariant. Okay, is this clear to everyone? Univariant. So now let us come to the statistical test that is used for univariant. Okay, so divide into parametric and non-parametric. Okay, if it is of the same group of people of one sample, it's paired. The opposite, if it is a non-parametric, the statistical test is Winston rank sum test. If it is unpaired in the parametric is unpaired t-test. The equivalent of that in the non-parametric is Mann-Whitney U-test. If it is something to do with correlation, correlation is cause and effect relationship, is called Spearman if it is parametric. If it is non-parametric, is Spearman. One way uncover is if there is more than two groups involved with this parametric, okay, then it becomes one way uncover. The equivalent of is crucial Wallace test. So is this clear to everyone? In your exam, let us test, how much we have gained. Okay, so the variable is non-parametric equivalent, and the data checks to unpaired variable. Which statistical test would you use?
Mann-Whitney.
Yeah, okay. We are using a non-parametric test for correlation. Which statistical test do we use? Yeah, so the clue is if it is causation, P with P. Okay, non-parametric S, you just add S. Okay, so I'm going to skip this one. Now there's another term called a chi-square test. Okay, chi-square test is used if you want to find about frequency and number
Sorry,
of
Guru,
proportion.
are you moving your slides or no?
Yeah, I'm moving my slide.
Oh, Okay, why is it stop following me? All right.
Yeah, I
We're
cannot
not
see it either.
It's still at the confidence interval page.
Yeah. We are seeing the slide 180 on the screen.
Okay, and you're not seeing after it moves.
No.
Okay, so let me try to do it all the time. Let me stop it and try to. Is it? Are you seeing anything now?
No?
No, still the confidence interval.
Now?
I'm seeing the correlation, the purple one.
Okay. Can you see correlation?
Yes.
Are you seeing anything now?
Still
No.
the same page.
Same page 180 slide.
Is it possible to stop sharing and then share again?
Stop sharing and share. Let me replace it and do it one more time. Are you seeing anything now?
Yes, the critical
Yeah,
review
page 1.
course.
Yeah. Can you see this slide now? Critical appraisal, the first slide.
Yes.
Yes.
Just give me 1 minute to load from my side. I think indirectly it happened more like a break. Just give me 5 minutes. Yeah. So this is more like a recap, the things that we have already covered. Can you see my slides moving?
Yes.
Okay. So this is just like a 5 minutes, the recap of the things that we have covered so far. Sorry, did we cover this slide? This one?
Sorry, the last one we saw was the 180, 180. So that's the last one we were able to see.
This one. 180.
Yes, this is where we,
Okay.
yes, that we were.
So this one, okay. Now in univariate, there are 3 different types of univariate. If you are just comparing one sample only, is one sample t-test. If you are comparing 2 independent unpaired, that means not related to each other, it's called student t. If you are comparing paired, mean of 2 groups of same subject undergoing 2 observation, like example, if you are comparing the weight of 2 group like A and B now, and after 3 months, 6 months, that is a pair T. Okay, but if you are in that you are just comparing the A and B of the individual in 3, 6, this one. Okay, so is this clear to everyone?
Yes.
Okay, so there are different statistical tests that we use for univariate t-test. Okay, so if it is a parametric, as a parametric is quantitative data, non-parametric is a qualitative data. Okay, if it is a peer, which we have already discussed about peer test. Okay, the equivalent of peer test, if it is non-parametric, this is the one. Wilkinson rank sum test. The equivalent of unpaired is Mann-Whitney test. If it is something to do with correlation, correlation is cause and effect. It's called Pearson. Remember, P is here, P is here. If you are comparing non-parametric, it becomes S. Okay. If you are comparing more than 2 groups, okay, if you are dealing with variance, okay, it's called one-way analysis variance. The opposite in non-parametric is called Kussel-Wallis test. Okay, so let us do a quick test just to know that we remember everything. Okay, so you are asked, is a univariate test, but the data are non-parametric. Which one is equivalent to non-pair t-test?
Mann-Whitney, you.
Mann-Whitney.
Yeah, perfect. Okay. If you are dealing with univariate test, which is non-variant, but it studies correlations, which test would you use?
Spearman.
Spearman. Okay, so yeah. Now we come to chi-square test. Chi-square test is a inference statistics dealing with any frequency and proportions. Okay, in this one, if exam, if they build 2 by 2 table, and if they talk anything about frequency and proportion, that's a chi-square test. Okay, but in this one, if the expected frequency is less than 20%, if the data is less than 20%, the test that we use is Fisher, which is the equivalent of chi-square. And McMinner is if there is something given with non-parametric data, paired equivalent, then it's McNemia. So this is the one that we used. There's something called degree of freedom. Okay, so you just need to remember the formula. If they ask about degree of freedom, the formula is number of rows minus 1 multiplied by number of column minus 1. So in an exam, they will only ask, the formula for degree of freedom, and they will give 5 options. You just have to take this one. Okay, is everyone clear about chi-square test?
That's about the degree of freedom, the number of rows in what, in the table or?
In a table.
Okay.
Okay.
It is usually, is it 2 by 2 table? So it is 2 row and 2 column, or?
Sometimes, the like when we did the mean and the medium formula, the data might be orange in, number of ways. Okay, the 2 by 2 table will cover in the 3rd session. There's a lot of 2 by 2 tables and formulas. So let us keep that for the 3rd session. Now we are talking about correlation. Okay, correlation. So We have covered the univariant. Now we are coming to the bivariant. Okay, so in this one, if you're talking about correlation, the range is -1 to +1. Yeah, I think last time we covered something about Kovacs alpha to do with the Kovacs alpha, where it is used.
Internal consistency.
Consistency.
Which one? Is it internal consistency?
Internal consistency, yes.
Yeah, and what was the range?
-infinity to 1.
Okay, so they might confuse you. Instead of that, they will ask, what's the range for correlation? So the range is different. Okay, so that is, keep in mind, for different statistical tests, the range are different. This we have already covered. If it is parametric, P. Pearson is also sometimes just given with this R. Yeah. Okay, so and for spaceman, sometimes they may just give RHO rho. Okay, so keep that in mind. So regression, causation is easy, cause and effect, but sometimes the confounders and other factors are also involved. So regression is one step further than correlation. In your exam, you just need to remember this formula. If it is a linear regression, linear means very simple, like continuous data with one independent and one dependent variable, it becomes simple linear regression. If the independent variable is more than one, it becomes multiple linear regression. Okay, binary data means male and female. Okay, if it is 1 and 1, it becomes simple logistic regression. If it is more than 1, it becomes multiple logistic regression. The way to remember is if it is something to do with qualitative data, logistic regression is used if there is one independent and one dependent variable. In an exam, sometimes this is the formula for linear regression. This is a formula for the one categorical variable. So A stands for intercept, B stands for regression coefficient. Unfortunately, you have to remember this formula. There's no any easy way out. Yeah. So anything to do with regression, linear regression. Okay, so keep that in mind. Now we have covered univariant, we have covered bivariant, then there's multivariant. In multivariant, you compare three different variables. Okay, so similarly in this one also, and you have to identify whether it's what kind of variant, more than two groups, if it is parametric, if it is independent, mean. Okay, so if it is an independent, it's factorial analysis. If they give something about dependent, it is Mankova. So the only difference is they will ask, the statistical multivariant mean analysis is used. Which analysis would you use for independent variable? For multiple variant. Would you use factorial ANCOVA or Mankova?
Factorial.
Okay, so the only difference is independent and independent. Keep that in your mind. Okay, so the same thing, I think this is just a simplified version of the things that we have already covered before, more in the table. So I'm just going to, so remember, non-parametric is median. Okay, if it is parametric, it's mean. So that's the way to remember. Proportion, okay, so this is the chi-square one. If it is unpaired, we use chi-square. If it is pair, we use Macmillan. So can you also give example, when do we use Macmillan? There was some percentage that we have covered before.
Less than 20%.
Yeah. Okay, so if they give you anything unpaired with frequency or proportion, chi-square. If they give you anything with paired, this is the one. Okay, so this the linear regression, which we have already covered. So this is more simplified version of the same thing that we have already covered. Okay, which one of the following is true concerning multiple regression analysis? Multiple regression. I think we'll just skip this one. This is the same thing. Okay, let us do this MCQ. Which of the following tests is useful if one tries to find out whether the mean IQ of a candidate taking MSI exam differs from the mean IQ taking GP exam. Is this paired or unpaired?
There are two different. They are unpaired.
Yeah.
So
Okay.
it should be unpaired t-test.
Unpaired test. Okay. But if they compare, A taking MRC exam with the same person, if they fail and take MRC exam the same in 3 months, what would you take on?
Paired t-test.
P test. Okay. So is this clear to everyone?
Yes.
Okay, so let me skip this one. Which of the following statistics would you use when comparing two groups to compare the risk of committing suicide after engaging in two different methods of SIM? Is it paired or unpaired? Two groups to compare committing suicide after engaging in two different type of self-harm.
Paired.
Is it paired or unpaired? There's two groups, two different self-harm. You're comparing two groups. They're not comparing the same group with the same treatment. They are comparing two different groups with two different
Unpaired.
unpaired. Okay. And numbers of suicide. Is it a frequency?
It's frequency, yeah. So
Okay.
chi-square.
Chi-square. Okay. Is it clear? So, but instead of that, if they just compare, the same person try to commit a crime, commit a suicide, it was not successful by overdose this time, and the same person tried to commit an overdose in 3 months' time. Try to find the number of people having the same kind of data. Which option would you check? That option is not given here.
Will be McNema.
McMillan. Okay. So is this clear? Yeah. Let's do the next one. Which one of the following measure used for correlation for non-parametric data?
Yeah, man.
If they have removed the non, which one would be the right option?
Pearson.
Pearson. Okay. Okay, so let us take 10 minutes break and we'll be back at 4. Yeah, and the last session, I think we'll finish in 40 minutes. Are you guys ready to take a break or you just want to continue? Break?
Yeah, thanks.
Yeah, so we'll be back at 4.
Hi, Chris.
Just checking with you guys. I know critical appraisal is a very dry topic. Are you able to follow my teaching?
Yes.
I find it very difficult to make critical appraisal an interesting topic. Sometimes when you're doing critical appraisal, it feels like 1 hour is like 7 years. And so, I'll put a picture over here. So we'll be starting the last session. Is this all right?
Yes.
For me to start?
Yes.
Yeah. Okay. So the last section that we are covering is more to do with biostats. And the good thing is we have covered about 8 individual studies in our last session. So there are different statistics or calculations that are asked for individual study. So if you're looking at cohort study, cohort where the exposure has happened, outcome hasn't happened. So and the question related will be incidence, relative risk, odds ratio, standardized mortality ratio. If you're looking for the case control where the outcome have already happened, and we go back to find out the risk factors, in those cases we find the odds ratio, odd versus probability. Cross-sectional is more of like the snapshot. So prevalence, we find all the population in that at that period. In cross-sectional, you also cover sensitivity, predictivity, positive, negative predictive value, and the likelihood ratios are also included in the cross-section study. If you're doing RCT, it will be a control rate, exposure rate, absolute risk reduction, number needed to treat, and RRR. These are some of the things that you will cover. In systemic review, it will be more like meta-analysis and forest plots. So those are the topics that will be covered. It's also good to know that each of the individual topics. For example, in the question they will ask, which of the study is good to study the incidence? Which study would you choose?
Cohorts.
Cohort, okay. In which of the study we use sensitivity?
Case control and
Cost control, okay. So let us go through each individual. So the first topic we are covering is cohort study. Okay, so for cohort study, number one thing we need to know how to make the 2x2 diagram. In the 2x2 diagram, always make sure the case and the control are on the top. Expose and non-expose are on this side. Okay, and after that you will put A, B, C, D. A is the true positive. Okay, true negative. So what have we put over here?
false negative.
And this one?
False positive.
Okay. And the case for the case exposure rate, basically it will be the case rate. So A divided by A plus C. If you're using for the control exposure, it will basically B divided by B plus C. So look at the topic case, it goes this way, control, it goes this way. Odd, basically what you do is you just compare. If you are asked the odd ratio in the case, you just compare with expose divided by non-expose. If it is an odd ratio of a control, you basically divide B divided by D. That's the formula. So the prevalence is actually the true positive and true negative in the whole population. Prevalence is all the case. So in the case, you need to find the total case, A plus C divided by the total. So that will give you the prevalence. If they ask about odd ratio, the trick is just do crisscross. A multiplied by D divided by B multiplied by C. So you need to know the formula. As long as you know how to do the 2x2 diagram and the formula, any question related with case control study, basically you'll be able to get the answer. Okay, now with a cohort, the cohort is the exposure has happened and we're looking for the disease that develop. So in cohort, the disease and no disease will be on the top, the other will be over here. So in this case, when we do the absolute risk of disease in the exposed, that will be exposed as a thing over here. So we go in this direction, A divided by B plus C. If you are going with the absolute risk for non-exposed is here, you go in this direction. Similarly, when you talk about odd, basically you divide this divided by this. It will be same for this one. Cohort, it helps to identify the incidence. So the incidence, for the incidence, the formula is more of like this one, exposed. So the incidence and absolute risk in the exposed basically is the same thing. For the odd ratio, the trick is crisscross. So there's not much difference between the case control and the cohort. The only thing you need to know is where to put the disease. Okay. So is this clear? Basically, it's just a formula and you need to be aware. Okay. Now there are other terms called risk ratio. Okay. So this is in the cohort study. So in the cohort study, when they ask about attribute risk reduction, ARR, basically what you do is you take the risk of in the exposed minus the non-exposed. So this the ratio of A divided by A plus B minus C divided by C plus D. So that is the formula of the attributed risk reduction in cohort study. If you're talking about the relative ratio, what you tend to do is the divide. So you divide the risk of in the exposed divided by non-exposed. So when you see attribute minus, if you see relative risk, you divide. Okay. Now there are some interpretations of RR, which is the relative risk. Relative risk is, in a simple term, relative risk in the exposed to the non-exposed. So if you get equal to 1, that means risk in the exposed is equal to the non-exposed. If you get a score more than 1, it means the risk in the exposed is greater than in the non-exposed. Okay. Similarly, you can make an other interpretation. If it is less than 1, you can say risk of exposed is less than non-exposed. There's another term called population attribute risk, which is also known as risk daddy. So in exam, what they tend to do is they will ask you to calculate ARR. They will give you the value of proportion of population exposed, and they will ask you to calculate the population attribute risk. So in this, just make sure you get the attribute risk reduction and you multiply with the value that is given. Sometimes what they tend to do is they would give you the value of population attribute risk, which is over here, and they will ask you to calculate the proportion of population exposed. So as long as you know the formula, you know what to do. Yeah, is this clear to everyone? So we have covered case control and cohort so far. Now in some condition, odd ratio might be equal to relative ratio. Okay, so remember in cases where the disease on the investigation is rare, in those cases only OR and RR are equal. So in exam, if they ask, when is odd ratio equal to relative ratio, the answer is if you see any rare in the option, tick that option. Okay, so now let us go to the third study, which is a cross-sectional study. Cross-sectional study is just a snapshot. So the formula for the prevalence is number of cases of disease present in the population at a specified time divided by number of people population at that specified. So number of cases divided by total population, and the formula is 1000 multiplied by 1000. If you are talking about the point, it needs to be, for example, at that point of time, like, do you currently have a depression? Like if I ask you, do you currently have a depression around 23rd of September around 4 p.m. Okay, so that is more like a point. If you're looking for a period, it might be like, have you had a depression during the last year? So it covers the range, the time frame. So that is a period prevalence. Lifetime prevalence, I think it's very difficult to do because you have to follow from the time of birth till they die. So it's less likely used, which is called lifetime prevalence. Okay, so it has got number of problems: recall, bias, fatality. People might die before the normal aging age. Okay, now the formula for the incident by definition is new cases. Okay, so it's similar to the prevalence formula, but the only difference is new cases by 1,000. Now this is the relationship between prevalence and incident. So the formula of prevalence is equal to incident multiplied by the duration of illness. So let us do a task. If the prevalence is 100 and the duration of disease is 10 years, how much how much incident is in that population?
10.
10. So you take on the other side. Okay. So these are some of the example. Incident is new cases, prevalence is the case that is already over there. Okay, sometimes they might also ask about crude rate. Crude rate is basically, in the entire population, and crude rate might be age. If you just want to find about particular age or this, it would be crude. There's something called adjusted ratio. I don't think they will ask you this more often, but just remember, if they ask about standardized mortality rate, the formula is number of death per year divided by expected number of death per year. So the formula is expected multiplied by 1,000. Okay, sometimes what they tend to do is they will give you the number of death per year is 100, the number of expected death rate is 10. Can you calculate the standard mortality rate? So how much would do you think the answer needs to be?
1,000.
Yeah. Okay. So now this is the way we design the 2x2 diagram for cross-section study. For the cross-section study, what we tend to do is we tend to put what we call the gold standard treatment rating scale on the top. For example, the gold standard for depression is big depression scales. Okay, so you put it on the up, and you have created a new rating scale, and you want to see, how much is it accurate to the bigs. So the new test that you have put, you put it over here: test positive, test negative. So in this one, true positive is this one. Okay, true negative is this one. Okay, this one is false positive, and this one is false negative. Okay. So are you guys clear how you make a 2x2 diagram for cross-sectional study?
Yes.
In exam, what they trick is sometimes they put the gold standard on this side, true positive on this side, and they will give you all the numbers and they will ask you to calculate. So make sure you turn the table and make the table in the right diagram. Is that clear? In exam, most of the time, if it is a cross-section study, make sure that the table that they have given is right. Okay, so always put the gold standard on the top and the new test on this side. Now there are some formula called sensitivity. For sensitivity, it's true positive. For true positive, what you have to do is A, and you go in this direction. So the sensitivity is in comparison with a gold standard. So gold standard, you always need to go in this direction. So true positive divided by A plus C gives sensitivity. If it is specificity, it's a true negative, you take B divided by B plus C. For accuracy is how much they are able to predict the true positive, true negative, true positive, true negative divided by total. So that is accuracy. So accuracy, is it validity or reliability?
Validity.
Validity.
Okay. So remember, no matter what they do, sometimes they will ask calculate the validity instead of accuracy. Okay, so validity basically means accuracy. Remember, all of this are the character of an instrument, not on the patient diagnosis. So, all the tests that we do gives the information on instrument, but it doesn't give any information on patient diagnosis. Is this clear? Sensitivity, specificity, and accuracy. It gives you information about how much accurate the rating scale is, but it doesn't give you anything about diagnosis. So to have more clarity, okay, before we discuss that, this graph is called receiver operator characteristic, okay, ROC graph. In exam, they might ask this graph. So where do we use the ROC graph? Which study? There's specificity, sensitivity.
Cross-sectional.
Okay, so if they put you a graph, they give you a long paragraph to read. Don't waste your time reading it. Okay, remember sensitivity, specificity, close your eyes, take on cross-section study. Okay, so now if you look at this, okay, this is false positive. Okay, so the false positive formula can be 1 minus specificity. So this is the positive rate, which is the sensitivity. So the y-axis will be sensitivity. This will be false positive. False positive is also known as which error?
Type
Type 1 error.
Okay, so sometime the option might be type 1 error. Okay, 1 minus specificity. So this is the line, the top one over line is also known as specificity. So this one is also specificity. Okay, and this is no predictive value. Okay, so anything under this and this is called accuracy. So if they give you this graph in exam, will you be able to say what graph it is? Yeah.
Yes.
Let us move to the next one. So let us do a task. Okay, what type of graph is this?
ROC.
Okay, which one is which one value is would be the lowest for specificity? Lowest. This is
1.
okay. In the above graph, what is under this graph? Under the curve?
Accuracy.
Accuracy. Okay, and to find out represent the best trade-off. The best trade-off is you have to find out this. Let me just go back. This arrow is called the best trade-off or the ideal clinical denominator. So if you look at this, you have to find out which one is closest to this one. Okay, so in exam, if they ask which one is the best trade-off, which one would you take? Which one is closest to this one? Which number?
4.
Okay, so are you clear how to answer this question if they receive a call?
Yes.
Yeah. Okay, so let's move to the
I
next one.
don't know how to have the trade-off point.
Take this one, yeah, and if you are confused, try to measure with a scale. Which one is closest?
Which one is closest to what? To what?
This one, this top. If you look at the graph,
Okay.
it says that this is the ideal clinical denominator. This one, tip, ideal clinical discriminator, ideal cutoff.
Okay.
So if they ask you which one is the best trade-off for sensitivity and specificity, this tip. Okay, so if you look at 5 is away from this one, 3 is slightly away, 4 is closer to this one. Is this clear?
Yeah.
Okay. Now there is other terms that in cross-sectional study which is called positive predictive value. The example is patient is not worried about how good is the test or not. They are more worried about what does this mean for a positive test or result. So we use positive predictive value, negative predictive value to explain to the patient, if this test is more positive, how from the gold standard or this one, what does it mean for patient to have a disease? What does it mean to have them, for example, schizophrenia? Okay, so for that we use predictive value. For the formula for predictive value is we go this direction. For sensitivity we go this. Okay, for predictive we go this way. Okay, for positive predictivity we take a divided by a plus b. For negative we take d, which is the true negative, divided by c plus d. Okay, prevalence, remember, predictive value and prevalence, they have got opposite inverse relationship. For example, if prevalence increases, the predictive value decreases. Okay, so in exam, if they ask, if the prevalence increases, which of the value decreases? So the option is sensitivity, specificity, likelihood ratio, predictive value. Which one would you take?
Predictive.
Okay, so is this clear? Yeah. Now the likelihood ratio is sometime, sensitivity and specificity is very limited to clinical practice because it only comments on the rating scales. Okay, when you use the other predictive value, it gives little much information about what the rating scales and having a disease means. But if you use likelihood ratio, it combines everything, sensitivity, specificity. So the likelihood ratio, statically, it should give more information about disease and the rating scale. So the definition of likelihood ratio is how much more likely is a positive test to be found in the person with the condition than the negative person. So it helps to compare between how much the true positive is with person not having the disease. So similarly, the negative is how much likely the negative test to be found. So just keep that in mind. Likely there are term called likelihood ratio and likelihood positive and negative. So the way we calculate is forget about this one. The easiest method to calculate is this one. The formula of likelihood ratio for positive is sensitivity. You find out the sensitivity divided by 1 minus specificity. 1 minus specificity is also called as
It's false positive rate
false
or
positive.
type
Okay.
1 error.
Yeah. So in exam, if they just give you, type 1 error is 10, sensitivity is 10. How much is likelihood ratio? Sensitivity is 10. Likelihood ratio, type 1 error is 10, so it's 1. Okay. Likelihood ratio is 1 minus negative is 1 minus sensitivity divided by specificity. Remember, no matter in positive or negative, sensitivity is always on the top, specificity is always on the low. If it is positive, the minus is for the sensitivity. If it is negative, minus 1 is for this one. Unfortunately, you have to remember the formula. Okay. What I would advise is, before exam in the morning, try to look at all the formula. Before going to bed, try to look at all the formulas. Okay, so let us do some MCQs. The ability of a test to correctly identify the true positive among the ill subject, what it is.
Sensitivity.
Okay, the test to correctly identify the true negative among the healthy subjects.
Specificity.
Proportion of the ill subject who are picked up by the test as having the disorder.
Positive predictive value.
Okay, so fourth, I don't think I have to do because it's just the opposite of that. This helps to determine how the result of diagnostic test influence the probability that the patient has the disorder.
Likelihood.
Yeah, if you see any probability, likelihood ratio.
Sometimes confusing to the definition of sensitivity, specificity, and positive predictive value and negative predictive value. What is the clue in the?
Sorry, can you repeat the question again?
The first 4 sentences to identify true positive in the ill subject, the difference between sensitivity, specificity, and positive predictive value and negative predictive value. Sometimes this confusing.
Okay, if you see anything like proportions or frequency, okay, it's predictive value. If you just see an ability to correctly identify, it's sensitivity. Ability to correctly identify true positive is sensitivity, true negative is specificity. If they discuss about proportions to pick up the test, if they talk about the ability of the rating scales to pick up the disease, is more of predictive value. If it is with the disorder or the case is positive, if it is with the controlled, okay, to exclude is the negative predictive value. If they ask about the diagnostic test and if they give any term like probability is likelihood ratio. Is this clear to you? I think this kind of question you need to practice. Yeah, the more you practice, the better it becomes. But in simple term, ability to pick what it's supposed to do, that is true is the sensitivity, ability to pick up the true negative specificity, proportion of a test to pick up the true test, that is positive predictive value, proportion of to exclude, and it's negative. If it is probability related to determine the diagnostic test likelihood ratio, then it's likelihood ratio. Yeah, so that is 2.1. Okay, now some of the basic simple terms like odd and probability. So odd is, for example, if you flip a coin, if you are comparing, the heads divided by tail, that's the odd of a head. If you are doing with the tail, similarly, you just flip it off. Probability is, the chance of having it. For example, if you are looking for the chance of head turning, if you flip a coin, head divided by number of tosses. So the number of tosses will be, 1, 2, how many times you do it. The formula for probability is equal to odd divided by 1 plus odd. For odd, it will be probability divided by 1 minus probability. Unfortunately for you, you have to mug up this formula. Yeah, there's no any easy way out. Okay. Now, I think this is the question that tricks you the most, which is called post-test probability. To calculate the post-test probability, there are 3 steps that you have to do. Okay, before that, you need to know how to draw the cross-sectional 2x2. Cross-sectional 2x2, you always keep the gold standard on the top and the rating scale that you have devised on this one. Okay, after that, you calculate the pre-test probability. So the pre-test probability is basically the prevalence. So in the prevalence, what you do is you find out all the diseases from the gold standard, A plus C divided by A plus B plus C by D. So first of all, when you calculate that, the number 1 step is you change to pretest odd. The formula for pretest odd is probability divided by 1 minus probability. Okay, so whatever you have got it over here, you put that number here. Forget about this one. After the pretest odd, you convert the pretest odd to post-test odd. To convert the pretest to post-test, the formula is you calculate the likelihood ratio multiplied by pretest odd. Would anyone want to give the formula for likelihood ratio? Positive.
Yeah, sensitivity over 1 minus specificity.
Okay, so you put that, you multiply it. After you get the post-test odd, you get the post-test probability by putting post-test odd divided by 1 plus positive odd. In exam, they will ask you about the post-test odd, and sometimes they will give you this diagram, and they will give you all the numbers. If that is the case, always think, okay, post-test probability, 3 steps I have to do. Yeah.
Yeah, it's also I think our post-test probability is also equivalent to positive predictive value.
Yeah.
Just as pre-test probability is equivalent to prevalence.
Yeah. Yeah. But like sometimes if you if you do by this way, it's easier to get it. Yeah. Sometimes if the data are missing. So this diagram is called likelihood ratio nomogram. This one is a pre-test probability. Pre-test probability is also known as prevalence. Okay, and this is a post-test, and this is a likelihood ratio. If the likelihood ratio is not given, then another term is Bayesian's nomogram Fagan. Okay, so also remember this one. In the exam, what they tend to do is, for example, they give you the pre-test probability is 5 and the likelihood ratio is 2.5. Calculate the post-test probability. So basically, you draw a line. Yeah, and sometimes they might not give you this, and they will ask you to name it. Okay, so as long as you know the diagram, you know what to do. For this one, can you just draw 2 by 2 diagram? I'll give you 2 minutes. Before we do this, what kind of study is it?
Cross-sectional.
Okay, so I'm going to give you 2 minutes. Try to do try to make a 2 by 2 diagram. Forget about all this calculation. Once you know the formula, you'll get it. The trick is, as long as you get the 2 by 2 diagram, that's the challenging bit. For 2 by 2 diagram, the trick is you always have to put the gold standard on the top, the digits, and the rating scale on your side. If you have finished, please give a thumbs up sign. So in this one, the information that we have is 150, of which 50 are clinical diagnosis with alcohol dependence. So remember, alcohol dependence is the one. So there are 150, 50 of them drink alcohol dependent. Okay, clinical diagnosis with alcohol dependence. 300 had no alcohol dependence. Having a cutoff of 2 points square in the gauge of indicate a possible alcoholism by 48. The alcoholism and diagnosis with 75 of without alcohol score less than. So on this side, you have to put the cutoff of 2 over and above, and the top one side you have to put alcohol dependence and non-alcohol dependence. So 2 minutes is up. Has anyone made a 2 by 2 diagram? Chika, have you made a 2 by 2 diagram?
I'm still struggling to.
I think for me, I did alcohol dependence and no alcohol dependence to be on top, and I did the cage to be on the vertical side.
Yeah.
And then the question said 50 for the alcohol dependence part. I got a total of 50, yeah. And then for non-alcohol, I got total of 300. And then because they said 45, we are positive. So what it means is A is 45.
Yeah.
And then C will be, of course, 45 minus 50, which is a 5.
Yeah.
And then for the other part of the non-alcohol, 300 were,
yeah,
because if 50 were alcohol dependent, then the remaining, they said 300 were not. And then they said 75 scored 2 above. So they've told us that any cutoff of 2 and above is positive, right? So
yeah,
B is 75, then of course 75 minus 300, that's the 225.
Yeah.
And then we now complete the box by summing them up.
Okay.
So in that case,
clear?
like, yeah.
Yeah. Is this clear to everyone?
Yes.
Okay. So the trick is, if you know how to make the 2 by 2, once you know the formula, you'll get everything right. Yeah. I'm going to skip this one. Okay, so in an exam, if this comes, make sure you put the suicidal on this one. You flip it. Okay, so I've just copied one of the exam question. So in this one, just flip the table. Okay, now we are going to the RCT. In RCT also, make sure that treatment and control on this side, positive outcome and negative are on the top side. There's something called control event rate. For control event rate, it's more of like this one, C divided by C plus D. If there's any topic, you just go in that direction. For experimental, it's the same with E, A divided by B plus C. For absolute benefit increase, it needs to be minus. If it is a relative risk, it needs to be this one. No matter what, even if it is absolute benefit or risk ratio, EER is always front. Yeah. Now there is something called relative benefit increase. For this one, you find RRR -1. So that is relative benefit increase. There's something called number needed to treat. If you are doing an RCT, this is very important. That basically that means number of patients that needs to be treated for one additional positive outcome. So this is the definition of NNT. The formula is 1 divided by ABI. ABI is basically EER subtracted by CER, experimental event rate minus control event rate. Anything less than 10 is taken significant. For to NNT to be accepted, it needs to be less than 10. Okay, odd ratio, basically you do the crisscross. There's something called patient exposure rate. We don't need that in detail, and they don't ask this more often. Okay, so let us do this MCQ. Okay, and in this MCQ, there are 2 questions, but let us just focus on the clinical response. Can you make the 2x2 diagram based on this information? $500 patient in 2 different medication. In this medication, 250 showed clinical response, and this showed 200 shows clinical response. Forget about the extrapyramidal. You need to make another 2x2 diagram for it.
So it means that it's going to be 2 different tables.
Yeah. So EPI is different and clinical response is different. Okay, so just focus on the clinical response. So the trick is, if you look at this table, the treatment and control needs to be here. So that 2 different medication needs to be here. The positive outcome and negative outcome here, and you just fill up the data. When you're done with the table, can you just let me know? I think this one is simpler than the one which we have done earlier.
Yeah, I can try. So for me, the table what I got was is anomaly group and the chlorpromazine group, right? And then the positive outcome, negative outcome. So for A, I got 250. And then for B, because the total is 500, it will be 250 minus 500, which is 250.
Yeah.
So AB is 250, 250. And then for the chlorpromazine group, 200 were positive. So C will be 200. And then D is 200 minus 500, which is 300. Yeah.
Yeah. Okay. So the trick is you need to know where to put this one. Yeah. And EER basically is this divided by this one CER, you get it. AER is, so once you know how to do the table, you can get all the values. Yeah, so it's not difficult to get it. So it's similar with EPSC. Okay, so let us do some few MCQs and I think we are done for today. Number of patients we need to treat with the experimental rather than the control to prevent one of them developing a bad outcome. What is this?
NNT.
NNT, yeah.
Yeah, the probability that the observed difference between the treatment is due to be chance, by chance.
Null hypothesis.
Sorry.
Then null hypothesis.
Okay, so we'll keep that, okay, let us just pause this one for a minute, okay? This gives the risk of an event in one group minus the risk in the other group.
Absolute risk difference.
Absolute.
Risks.
Yeah. Okay. This is a risk of event divided by the risk in the other group.
Relative risk.
Okay. Risk of experimental event in the experiment group relative to the control group. This is the same question, okay? The proportion with the event of interest in the intervention group. ER. Okay, proportion of the event in intervention reduces in the event. Okay, let us skip this one. I think that's the same question framed in a different way. Okay, so the only thing we didn't got is p-value. Okay, so p-value, the definition is the probability that the observed difference between the treatment is due to by chance. Anything probability with a chance is p-value. And what is the ideal p-value that we aim for?
Less than 0.05.
Yeah.
5%.
Yeah.
Is this a forest plot?
It's forest diagram.
Yeah, so I still remember, I think it must be in 2013 when I did my F2 and I decided to do trust grade in psychiatry. In my first week, the consultant asked me to present a journal presentation and he gave me a critical paper and he said it's a forest plot that you have to interpret in a critical appraisal. I've never done this forest plot, so I thought forest plot was something like this. Yeah. Okay, and this is actually the forest plot. Okay, in forest plot is used for meta-analysis. So in meta-analysis, what they have done is, different type of RCT. There's a study. Okay, in this one, the central line can be relative risk as well as odds ratio. Okay, so this one, the big what we call the box. What is this box called?
The weighting.
Is it the weight of the study?
Yeah, what's
Yes,
to
the
study the magnitude of the study?
Yeah, and what is this line called? This line.
Confidence interval.
Okay, and what is this line called?
Line of no effect.
Okay, and what is this diamond sign called?
The weighting of or cumulate I think
try to
it's
summarize
the
everything.
total all the studies.
Yeah, and keep it over here. Okay, and also look at this side, whether it favors the control, whether it forms the treatment. Okay, so these are all the things that you need to know. Yeah, and in this one, okay, this is for the control of total. This is a summary of this and this. Okay, so when we do exercise, we'll have more clarity. Okay, now there are some of the terms. I think this question was asked by someone. Did Emma ask this question before?
Yeah, I asked in terms of the hazard ratio and line of significance.
Okay, so confidence interval. We can calculate confidence not only means but also range of other sum. So the confidence interval also has some relation with the other one. For the outcome measure, if confidence doesn't embarrass value of no risk, the statistical difference cannot be interpreted. So the value of no difference, no difference means there's no any difference between the study, and then we accept it. To accept the confidence interval in practice, the odd ratio ideal is 1, relative ratio is 1, absolute risk reduction is 0, relative risk reduction is 0. How do we calculate relative risk reduction?
RR minus 1 or ERR over CER.
No. Relative risk is EER divided by CER, but relative risk reduction is 1 minus RR. And RR is EER divided by CER. Is this clear?
Yes.
We had already covered this one. What's the formula of NNT?
1 over ARR.
Okay, and EER minus CER is absolute return. So the value is infinity. Okay, unfortunately, you guys have to remember this one. Mug it up. Yeah.
So
Okay,
for cohort study is relative risks, right?
Cohort study.
Yes.
Relative. It can be for cohort study as well as for our city.
Okay.
I think in our city also we have done relative risk.
Okay. Thanks.
For our city is a ratio between the risk. For relative risk is more with cohort study.
Okay, thanks.
And I think this is the last slide we have. One we'll do with a forest plot. Okay, so this is what diagram is this one?
Forest plot.
Okay, so in this one, the pool ratio of relapse in those taking placebo. So the pool is this diamond. Okay, so what's the value of the placebo? If you look at this one, this is placebo, this is lithium. From this diagram, can you tell us which one is the pool ratio of relapse and placebo?
Is this 60%?
60%, yeah, this is the one. Let us see the overall pool value. The pool ratio of relapse in lithium.
40.
40.
Okay. If you have to calculate the risk reduction in lithium group, how much is the? What's the answer?
40, 60 minus 20, 40, 6, 20.
20,
yeah.
okay. Number needed to treat. Prevent the relapse. So we have already calculated, that's 20. 1 divided by 20%. So how much would be the answer?
0.5.
It will be 5.
That's 5, rather, sorry.
Okay. So are you clear how to do it? In exam, instead of the pool ratio, they might ask you about this particular study. Okay, they might ask, what is the risk relapse of Bowden, okay, in the placebo. So this one, okay, so they can ask about each individual study. So as long as you know where to look for, you know how to calculate the AR and number needed to treat. Okay, so I think we have covered everything today. Is there any question or any topic that people want to ask question? You can on your camera, we are finished now. I don't have any slides left. And I'm just sticking with the syllabus which is given in Royal College of Psychiatry. I'm not teaching anything outside the syllabus. And I hope with this knowledge, you guys will feel more comfortable to do any critical appraisal question that comes in your exam.
Yes.
Yep. I think only you had some question about, statistics, this number. Do you feel more confident now?
Yes, I think I can be able to iron it out. Because I was having issues with correlation, choosing between Cox proportion and the log rank log regression or something. I think based on what you explained, I think I'll be able to iron it out if the question comes up.
If you see any like confounders or anything, log regression. If you see any death, a hazard ratio. If it is just simple, log rank, for the causation.
Yeah.
The other trick is if they ask about statistical tests, try to find out whether it's univariant, bivariant, multivariant group. Then you find out whether it's parametric, non-parametric. Okay. As long as you can find that, if it is a correlation, then it's Pearson and Pearson and Spearman. The other one is paired this. So as long as you know how to answer those 3 or 4 questions, you'll be able to take the right answer.
Yes.
Yeah. The other thing is, like if any of the tests, the first trick is find out which type of study is it. If you find out which type of study is it, then it becomes easy to narrow your question out. The other advice I would give is in the exam, don't spend your time reading the long paragraph. Go to the question straight away and see what they have asked for. Okay. Based on that, you find the clue in the paragraph. So that will help you to answer. If you see any diagram of survival curve, survival analysis, cohort study. Okay. If you see any question with rating, is cross-sectional study. Okay. If you see anything with forest plot, is meta-analysis. Okay. Just looking at the diagram, you don't have to think which study is it by reading the paragraph. The clue is already there. For example, if it is receiver under curve comes, which study is it?
Cross-sectional.
Cross-sectional. Okay. If you see any sensitivity, specificity in the question, it's a cross-sectional study. So you don't have to think about is it cohort study or cross-sectional? The other study. Okay. If you see any flow chart or consort, it's RCT. Okay. If you in survival analysis, if you see the outcome at the end, okay, and it's always retrospective cohort study with the outcome. If you see the outcome in the picture.
Yeah.
Okay. So I think as long as you know the trick, the most important thing is ticking the right answer. After passing the exam, you can develop your knowledge or do whatever you like. The first thing you have to do is the priority is to pass the exam.
Yes.
Yeah. So
And
all the
that we
best
shall
for your
pass.
exam and hope to hear good news from you guys. Yeah. Take care
Thank you very much.
and have a good weekend.
Thank you so much.
Okay.
Thank you so much.
Okay.
Thank
Take care.
you.
Bye bye.
Bye-bye.